It's exactly the same thing, but in different analyses. We can calculate, instead of doing that ugliness that we just did with the hand calculations of all those correlations, we can do 2 multiple regressions and get the exact same values. The first one estimates that coefficient, the effect of lax parenting on peer behavior. And you do that, our outcome, and again, you're thinking, but aren't we talking structural equation modeling? Which we are. But it's what's kind of key is, think about it. I'm talking about that mediating variable now as an outcome. And it is. When we do SCM, we'll have all those mediating steps. They're also out. It's a predictor of the next variable, but it's an outcome of the one before it. It's both. What was the old? See, I'm gonna see. This is really bad because there's the younger people and the older people. What's the Saturday Night Live? It's a floor wax and a toothpaste or something.
I don't know.
Yeah, it was like a famous Saturday Night Live skit of kind of making fun of those. And it's more. It can do 2 things. You can wax your floor or brush your teeth with it. It was much funnier than I give it credit. It's got to be on YouTube. I got to get that one. Anyway, so it's both. And that's conceptually important to kind of keep in mind. It's both of those things. And you see it literally here because we're doing it as its own multiple regression analysis. Predicting peer behavior. Our outcomes peer behavior. Our predictor is lax parenting. I do a multiple regression. Remember, this is what we just calculated. It was 0.3188. I do the multiple regression analysis, and there's my beta. Exactly the same thing. So much easier than doing all that math. Then this part, lax parenting and peer behavior predicting child behavior, is the second multiple regression equation. Now we have lax parenting and peer predicting child problem behavior is our outcome. So the outcome is changed. Now, actually, think about it just a minute ago. It's kind of that's the first time we've done that one of our predictors as an outcome. We've always done the outcome as the outcome, but that's what makes this kind of cool. And why you can't do it just through normal multiple regression, because in a normal multiple regression, your predictors are never outcomes. They're always predictors. So anyway, we do a multiple regression, lax parenting and peer, 2 predictors, and our outcome now is child problem behavior. We're just estimating those 2 paths. And I do the multiple regression, and voila, exactly the same. It's the exact same betas. Far out. It also helps to illustrate, and that's why we interpret them as standardized betas, because they are standardized betas in this very simple model. Now, there's more to this, and this will become important. Well, we'll see this in SCM. But remember, there's additional things in our model. See, because I changed, that's the old example. You're talking, what's he talking about? Study hours and grades. Because I took out my made-up data and put in real data, and I didn't change the text. You know how much work it was to redo all these slides just to change the numbers so it was based on real data? But see, I'm responsive to students. You guys said, let's do some real data examples. So I redid it with real data. Just finding data that did this was a headache. Anyway, oops, typos. Sorry, it's not study hours. There's additional variables influencing child behavior problem other than lax parenting and peers. It could be the neighborhood you live in. It could be, do you work? It could be sibling behavior, family discord. All sorts of things could be handling it beyond lax parenting. And the effect of all those other variables are called disturbances. You also see sometimes they'll call them, it's exactly the same as residuals and errors. They're often used interchangeably. In SCM, we'll kind of make, you may see a little of a distinction when we get to latent variables. and measured variables, but anyway, disturbances. It's an easy term to get comfortable with. It's just some of the terminology we'll start using, and it's just the error. It's the residual. It's everything that we don't understand, that we're not predicting about that variable. All the leftover variance that we're not able to predict. Those are disturbances. Exactly the same. So we can draw in our path model this way. We have that little circle up there, D1, disturbance 1, our first disturbance. Notice it's a circle. And this is kind of the approach the kind of the formal approach we use when we're drawing SEM causal models. If it's something that's actually measured, if I have data on it, if I can say that score, that score, that score, it's something I've measured. It's a measured variable. We draw them in boxes, little rectangles. And if it's something that I don't actually have measured, we draw it as circles. Now, in this case, or circles or ovals. In this case, I didn't measure. That's why it's a disturbance, is it's all the stuff I didn't measure. So we put it in a circle just as a way of differentiating it. And we're going to call it D1. And to estimate the disturbance, it's the effect of everything else on the behavior scores. Because, right, parenting won't perfectly predict behavior. To perfectly predict behavior, I need everything else as well, all that other remaining residual noise. So we look at that we go back to this analysis where we have lax parenting as a single predictor of peer behavior. And think about it. So what I've got there, ignoring the disturbance for a minute, that model, lax parenting, the regression coefficient's 0.3188, that accounts for how much of the variance in peer behavior. It accounts for R squared amount of the variance, right? That's if I do the R squared, that's how much of the effect that parenting has on peers is equal to R squared. How much is everything else that's not accounted for in my model? The disturbance. How much is that? How much variance? It's 1 minus R squared. So the disturbance reflects that 1 minus R squared variance that's unaccounted for. Now remember, that's R squared, that's variance, and we're talking about these standardized betas, which are standard deviation scales. So I take the square root of that 1 minus the R squared, right? The standard deviation is the square root of the variance. So if the disturbance was reflecting 1 minus R squared of the variance, I take the square root of that to make it a standard deviation influencing the peer behavior. And that's the path of the disturbance, is equal to 1 minus R squared. And it took me a while when I first, many years ago, when I was like your guys' age, for that to sink in. Well, of course, when you think about, but it wasn't explained to me that way. It's just like, oh, here's the formula. It's like, well, why would you do one? Well, of course, because it's how much left over is 1 minus R squared. That's the variance I don't know. And you just take the square root to make a variance a standard deviation, because the paths are standard deviations. So we look at our R squared for that model, and it was 0.102. So again, it's kind of wild, isn't it? The R squared predicting a predictor. But the model, that part of our model accounts for about 10.2% of the variance in peer behavior. And that path, then we just plug in 1 minus 0.102, gives us a square root of 1 minus 0.102, gives us the square root of 0.898, or that path is equal to 0.948. That's the path. That's the effect of everything else in the universe that might be influencing scores. Then, to calculate D2, the disturbance for the second variable, in this case, our outcome, child behavior, we do that same multiple regression we did a minute ago, where we have our outcomes, child behavior, we have two predictors, lax parenting and peer behavior. The R squared, we go back to the analysis, we look up the R squared. Our R squared is 0.489. the square root of 1 minus 0.489 is 0.715. That's the path for our second disturbance. That's the variance, that's the effect of everything else that's influencing child behavior that's not peer behavior or parenting. That is a full structural equation model, a nice, beautiful little path model.
We did these.
We did those in class, yes.
Yeah.
Yes, you did.
I am having
Yes.
fun.
We calculate all that. And then you can see once
Sorry.
you kind of get the handle, it's conceptually, then you kind of just need to understand, okay, what the paths are. They're standardized betas, and those disturbances are everything else, and the bigger the path, the more squishy, the more other stuff are playing a role. So you can see we didn't do a great job predicting peer behavior because that path is 0.948. We did a bigger job predicting child problem behavior because that disturbance is only, the path is 0.715. So it's kind of estimating more closely. You might ask, well, what about lax parenting? Shouldn't we have why do we have a disturbance on those two, but we don't on lax parenting? But we're not predicting lax parenting. It is what it is. So there is no error in it because we assume there's no error in it. In a couple of weeks, we'll look at, maybe we want to say there's error in that measure. I mean, of course there's error in our measure of parenting. I mean, there's no, I'm sure I used this analogy last week. I can't stick the thermometer in your mouth and measure how lax your mom was. So there is error, but we assume there's no error. We'll learn how one of the cool things with SEM is we can factor in that maybe there is error in these measures. But for now, we'll just assume there's no error. And remember, multiple regression and ANOVA assume there's no error in anything. Now we're actually able to, notice now we're starting to talk about we can model error. We're going to be able to do things with it in a few weeks. So that's our path analysis. We could have got this published, but I don't think we ever did. Though maybe, it was so long ago, I don't remember. It's probably somewhere in the study, somewhere, because those are all variables I was interested in. Anyway, so now let's look at the direct, indirect, and total effects. Now, remember when we did the sequential multiple regression, our model implied indirect effects, but we never estimated them. Because we were always only predicting the outcome. We never did that. We never used we never used those mediating, those predictors as outcomes. We only ever predicted the final outcome. Now we can estimate. We got the direct effects, but we couldn't estimate the indirect effects. Now we can. So, the effect for lax parenting, well, the direct effect is that unique effect it has on the outcome unrelated to everything else in the model. That's that single path between lax parenting in blue and child behavior. That's 0.19096. And that, to interpret that, we can think of that as a 1 standard deviation increase in lax parenting leads to a 0.19 standard deviation increase in behavior problems that's unrelated to peer behavior. So it doesn't mean that, remember, that's just part of the effect. That's the effect that lax parenting has, not because you're hanging out with bad kids now. It's other stuff, is 0.19. And we can calculate the indirect effect. And to calculate the indirect effect, we just multiply the paths along the way. And if you think about it, it kind of makes sense that you'd multiply. You wouldn't add them, because you multiply because if I increase this 50 by half, and then I increase that by half, it's not half and a half makes a whole. No, it's half, and then it's half again, and then it's half again. And so you multiply the paths to get the indirect effect. So 0.3188 times 0.61438 gives us 0.19591. That's the indirect effect through peer behavior. Nope. Nope. That's it. So the products, and there can be, in more complex models, we'll see in a minute, you can have multiple indirect effects. But you just multiply them. That's how you get them. So that tells us a 1 standard deviation in increase in lax parenting leads to a 0.19591 standard deviation increase in behavior problems due to hanging out with more problem peers. They're both effects on the same outcome, just kind of how much is this way and how much is that way. Kind of different processes. Now we're looking at this, what's fun with SEM. We could do a fun with SEM video instead of fun with lax.
Yes.
That's right. Okay, now, see, we can't do it twice. Though I bet you Melissa will say we should give you a hard time when she'll throw you under the bus.
Causing trouble.
I am. I need some. I was crunching a lot of numbers this weekend. I need some sleep. Where was I? So you can think of, we've estimated the direct effect and the indirect effect, and what we're getting at is the process. You know, we're often interested, whether it's teaching, whether it's developmental psych or clinical psych, we're interested in what's the process. Okay, I see this and that. What's the process that gets you there? And there's multiple, we're starting now to look at multiple processes that explain why being a lax parent leads to behavior problems. In this case, it's kind of wild that if we look at the two of them, they're about the same size. About half of the effect seems to be due to I'm a lax parent and my kid starts hanging out with the wrong crowd. And about half of it seems to be due to other stuff. And it may just be I'm a lax parent and my kid doesn't feel I care about them. That was one of our big hypotheses. Actually, kids don't think I care about them if I'm being a little too lax. So they start to act up.
So if they're a lax parent, if your kid do not have friends, then the effect is not as big.
Yes, these are all gross average. So points of intervention might be keep them away from the bad friends and all of a sudden lax parent. But then there may be other it's like squeezing a balloon.
Yes.
I mean, but on the other hand, if you're a lax parent, you're not keeping your kid away. By definition, if you're a lax parent who gets in and says you're not hanging out with Mason anymore, that kid's in trouble. I actually had some parents that said that. Too much disclosure.
Hard to believe. Yes.
Too much information. Then you're not a lax parent anymore.
Right.
So you're changing the predictor. But you can see, actually, that's actually a good point. Another thing we did this weekend, we had these models, path models. Actually, I'll share some with you. And it comes down to, and this is a point of intervention. So writing up a paper is saying, it's this mediator, it seems to have a big effect, and that's something, I can't change mom's education, but I can do an intervention that works with moms to get them to talk more to their babies. And that leads to better language outcomes in young children. That's a point of intervention I can do. So we wrote that into the paper. So sometimes that's another way of thinking about these because we're understanding the process. Understanding the process, you start to notice, are there some of these variables for all the clinicians and therapists, whatever, you can start to recognize maybe that's a point of intervention and break the chain by saying, in this case, if there's a way to keep them away from the bad peers, that's cutting out half the effect.
Or you can use this to measure intervention somebody's done and see if it's actually had the effect they're saying.
Yes.
Yeah.
And how's interventions working? Right. I mean, that gets back to the process. We're often interested in understanding the process. How does something work? Not just A causes B, but the mechanisms. And again, I think an important, given our education and psych sort of areas, often, yes, you can think of these as points of intervention in between that you might be able to hold off some effect. It's also going to be useful if you find that mediator is really small. Maybe that's not the best intervention, the best point of intervention. Bonnie Brandt?
I know what you're thinking. No.
Someone many years ago, on my postdoc, we coined a term after someone that had this intervention model that came down to A causes, and remember the multiplying, 0.5, 0.5. So you can see mediation, indirect effects can get very small if you have a lot of steps. Their whole intervention was based on A causes B, B causes C, C causes D, D causes E, E causes F, and I'm going to, I'm going to break this, and it's like the effect size is this small. You're never going to be able to see it. I mean, even if you have an effect, you're not going to be able to measure it, and if you are able to measure it, it can't be giant. You can't have a long causal sequence and end up with this monster indirect effect size. It doesn't work. So for decades after, we coined a term named after this very nice person. I'm sure it's gone on and done quite well. Anyway, what time is it? I may want to cut that. 6:58.
Yes.
Okay, so about an hour, almost 2 hours in. I may want to I hate putting stuff on the internet. What's the chance they'd ever notice?
Yeah, just to play safe.
Just to play it safe. I don't want to get hate mail. Anyway, so that's our direct and indirect effects.